Howdy. We are grad team number 1 doing our design project for Milestone for the DeathSlinger. Part of this team, we have Brandon, Clara, Jack, and myself, Taylor. Now we'll talk about our breakdown of our project. So the primary function of this project was to provide fun for the whole family. And to do this, we have a couple main components, such as the frame, the arm, the counterweight, seat, and the fasteners. Each of these were made individually in SolidWorks, and then we combined them together to create an assembly. On the next slide, we'll get to see the assembly in action. You'll notice that once the weight is released, it will begin to drop down and the person will be flung through the momentum into the water, hopefully feet first. There's a hydraulic system to catch the weight on the other end. Now Claire will take us through some of the calculations that it took to get the right measurements for this.
Howdy. So during our design process for this, we decided to lay out some requirements for max height and velocity that we wanted the victim to undergo. So for max height, we decided upon 10 meters. That's the height of the tallest diving stand in the wreck. The max velocity, we decided on 15 meters per second, or about 33 miles per hour. Humans can undergo approximately 55 miles per hour of speed, but we decided to go a little bit lower than that. After deciding upon this, we were able to calculate what the angle of release should be, alpha, and the length that the arm should be. Using those two values, we did some energy balance equations in order to solve for what masses each of the different components needed to be in order to meet the height and velocity requirements. Those equations were inputted into a Excel spreadsheet, which was used to ensure that the max velocity and the max height were not exceeded. This was used to calculate an input from the team members, what the different masses of the different components should be, and what the lengths of each arm should be.
So the first part that we developed was what we call the A-frame that kind of housed the rest of the attraction. So from the dimensions called out on the previous slide, we first developed a 3D sketch and kind of the SolidWorks weldment features, and then assigned different structural members to each of those sketch components. Some of the structural members called out in the balloons on the left-hand drawing include for the legs of the frame would be a 16-inch outer diameter, 1-inch thick round tubes, various sized I-beams spanning the distance horizontally and vertically to provide strength and stability. A couple of C channels that are kind of custom coped to fit the curvature with the steel plate on top for safety purposes, steel plates to attach the pivot housings at the top of the A-frames, and then the walking platform is made of 5 other I-beams, 5 horizontal I-beams with a 3/4 inch thick perforated steel grate for the walking platform. And then on the right, we have some of those structural member cross sections.
The pivot arm was also created using the SolidWorks weldment. The main function of the pivot arm is to connect all 3 of the other main features, so the base, the launching seat, as well as the seat that acts as the counterweight. So the seat is connected at this point here by these 4 1-inch bolts, and the counterweight is connected at this U-joint on the other end. And then the pivot point occurs closer to the U-joint than the launching arm, approximately 1/4 of the way across the arm.
Next, we'll talk about the counterweight drawing on the left and the seat drawing on the right. The counterweight was designed around the weight from Clara's calculations in order to achieve the velocity set as hollow, which allowing the victim during the ride. On the right-hand side, you can see the seat, and some important things to note are the detail holes and clearances needed to bolt and weld the mounting sleeve and seat assembly onto the arm made by Clara.
For the DeathSlinger fabrication plan, first for the frame, all of the structural members will be cut to length in the factory, and for tolerancing purposes, they'll be cut slightly oversized, about 1/4 to 1/2 inch to allow for some final sizing at the location where things will be later assembled and welded together. The arm will be fully manufactured in a factory in a metal fabrication shop. So cutting all of those structural members, those tubings, and then welding them together with the gussets for support. For the counterweight, we will manufacture that through a two-part plaster casting system. That's very beneficial for large parts. And then those two halves will be bolted together, and then the seat and the bar kind of holding that rider will be welded in additionally. And then lastly, for the seat, it'll be made out of sheet metal cut to size in the factory and then folded to match our curvature, and then custom profiles will be water jet cut and welded to the remainder of the seat body.
Throughout the fabrication of this process, we learned a lot of lessons. So for the DFMA, we utilized SolidWorks Weldman's design features and was able to actually implement that in a working design. For the design methodologies, we created the most dangerous, exciting ride that hopefully will not kill anyone. Successes? Physics says that this ride should work as long as people follow the warnings and other regulations that would keep them safe when riding it. Some of the challenges is, unfortunately, we can't actually build this ride because of how large it is and how expensive, but there would potentially be tolerance issues with the assembly for this ride.
Warnings and disclaimers. This roller coaster is extremely dangerous and requires extensive training in order to ride. Serious injury, death may occur if proper landing techniques are not adhered to. The park does not provide this training. The training for landing techniques can be found through USA Cliff Diving at cliffdiving.us or any similar cliff diving company. Warning: do not ride the DeathSlinger if under the weight of 68 kilograms or 150 pounds imperial. Do not ride the DeathSlinger if you cannot swim. Do not ride the DeathSlinger while pregnant. When riding the DeathSlinger, always attempt to land feet first in the water in order to prevent injury. The DeathSlinger may cause serious injury, including but not limited to skin rash, excessive bruising, whiplash, internal bleeding, fracture to broken bones, broken ribs, brain trauma, paralysis, and PTSD. Victims of DeathSlinger agree to the following statements when getting in line to ride. Accept that you are riding the DeathSlinger at your own risk. Accept responsibility and liability for any injury or death that may occur while riding DeathSlinger. And 3, agree that by riding the DeathSlinger, you're putting your life on the line for the purpose of getting a thrill.
Come and ride the DeathSlinger today.
DeathSlinger today.